Hi everybody, my name is Emma. Me, Jordan and Amy from Command Shift are going to be presenting our group project app Quizbiz. So here is the what and the why. So our app is a custom quiz generator and it takes category and difficulty parameters and returns a bespoke quiz for the user to enjoy. For this, I'll show a demo of how it works exactly. So the app does have potential utility in education and recreation, and we're able to use it across a wide range of curriculums given the customizable category parameter. So as you can see, there's quite a lot here. I'm just going to stick with general knowledge. So when you click the answer, whether it be correct or incorrect, if it's correct, it'll go green. If it's incorrect, it will go red. So I will try and get a good score. Brilliant. Perfect. So when a user gets over 50% of the score, there will be a confetti React library that comes across the screen and a congratulations message. When a user gets below 50%, there will be a sad emoji icon and a different error message saying better luck next time. So for this app, the technology can be used in classrooms to promote engagement with learning, and the competitive leaderboard here in particular can achieve this and can promote users to use the app more just to get to the top of the ranking. So we're on to the front end part of our project now and what we used. I'll show the code for this part. So we used React to build a single page component-based application, as you can see here. React's native state management capabilities allowed us to render a seamless interactive user experience. And we also used React libraries to achieve a more aesthetic and user-friendly experience, like with the React confetti I showed in the demo. We wrote the skeleton of our pages in HTML, and for the styling of our quiz app, we used vanilla CSS, and this made it easier for everyone to incorporate the styles and just follow the basics of CSS. I will now hand over to Jordan so he can discuss the back end of our quiz app.
Hello, thank you very much, Emma. So, yeah, my name's Jordan, and I'm going to be taking you through the back end part of our app and also some roadblocks that we hit along the way during development. So, I suppose the most important part of the back end is where the questions actually come from. They're sourced from an API called the Open Trivia Database. It's huge, there's well over 4,000 questions on there in varying categories and difficulties. So, I'll just show you how that works very quickly. Here you can see an example query. So here, the parameters are, we've got 5 questions, we've got category 23, which is the history category. We've got medium difficulty, and the question type is of multiple choice as opposed to true false. We didn't actually end up integrating this parameter into the user experience for reasons I will get into very soon. And so, yeah, for logging in and authenticating users, we used Firebase. Here you can see lots and lots of pretend emails that we used during the development process to create and authenticate users as they log in. And the reason that we used Firebase to log in was because we wanted users to be able to contribute to the leaderboard. I know you've seen it already, but I'll go into a little bit more depth here. So you can see that the users aren't actually ranked by total score, because otherwise Emma would be winning. They're ranked by average percentage. The way the percentage this works is it's updated on a rolling basis. So it'll send off your current percentage from your most recent quiz, and then it'll calculate that against your previous percentage and create a kind of rolling average, which is really good because it keeps it competitive and keeps users accountable. You're only as good as your last few quizzes with this app. And the leaderboard data is stored here. We used the Cloud Firestore NoSQL database, which was really handy because it allows you to have very customizable key value pairs. Here we've just got exactly what we need. We've got average percentage, total score, and username here, which is Emma. This is all created in the app and then sent off to the Firestore when a user submits their quiz, provided they're logged in, of course. Yeah, so that's how the back end works. A few roadblocks we had were there are very few true-false questions in the database, so we used to allow users to choose whether they wanted multiple choice or true-false, but if they chose true-false, then there'd be very few questions returned, so we removed that parameter. And there's also very varying amounts of questions in certain category and difficulty combinations. So what would happen before is if you selected more questions than exists for a particular set of parameters, it would result in a bad quest and we'd get a lovely red screen of death because the request can't be fulfilled by the API. So I'll just show you an example. This is how we decided to tackle that issue. If I want a quiz about celebrities at medium difficulty, it's going to cap at 31 questions because that's how many questions exist. This is a feature we implemented just to make sure that there are no bad requests possible. Those are some roadblocks that we had and which we thankfully got past. As for what else we would do given more time, we would have quite liked to have the leaderboard more customizable. So that at the moment, as you can see, the leaderboard is very much it's a total score, any possible category or difficulty. We would have liked it to be filtered by category and difficulty, so you couldn't just see who's the best overall, but you could see who's the best at history, who's the best at art, who's the best at general knowledge at medium difficulty. That's what we would like to do next. And another thing we would do given more time is that the app currently isn't the most responsive to different screen sizes. We would like it to be more accessible on tablets and phones, particularly tablets for the education setting. A lot of classrooms do use tablets these days. Okay, I think that concludes back end and the roadblocks section of our presentation. I will now hand you over to Amy. Thank you very much for listening.
Thank you, Jordan. Hi, I'm Amy. Although our project was small with a relatively small code base, there were echoes of agile software development within our project activities, workflows, and team roles. We first conceptualized the project design using Figma and then prioritized the project requirements by applying MOSCO. MOSCO stands for must have, should have, could have, and will not have. Next, we define our team roles with each of us working on a specific component of the project. This method is suitable in a small group. We worked collaboratively, albeit remotely, with the help of a simple ticketing system, GitHub, Slack, and Google Meet. We also had the opportunity to develop personal skills and to learn from each other. Due to the size of the project and the team, we were able to perform continuous manual testing and bug fixes. The React framework we used provided instant feedback, which enabled us to make quick decisions in ways to improve a feature or the project on the whole. So essentially, retro on a small scale. It was also fairly easy to do mock programming in a small team and to keep each other updated on the progress of the project. The Agile Manifesto places more importance on people rather than the process. Therefore, people and the way they interact with each other has a marked impact on productivity. Although this was our first software development project, we feel that we have managed to incorporate elements of Agile and have successfully worked as a team to produce an app that we can be proud of. And finally, we would like to thank all the tutors of Command Shift for sharing their knowledge of software development with us and for all the help rendered. It has been an interesting and challenging journey, one we hope to continue for years to come. Thank you.